Hi, this is the third presentation in the ABC Player playlist, and in this case we will be addressing the hints that I can offer you to carry out stage 2 of this assignment. The learning outcomes that I expect you to achieve through this presentation are indicated here. I expect that you will be able to list what are the main blocks needed to implement stage 2, and also to explain the operation of the ASMD chart for the corresponding control path. Now please recall that on stage 2 of the ABC player we are interested in downloading an ABC file containing a tune and to play it whenever the play button is pressed. We will not address the recording feature, which is only considered in stage 3. Now we will start from exactly the same block diagram that we had for stage 1. Actually, this is exactly what we had in stage 1, and I have just added the play button, in this case, to the control path. The UART receiver is now represented with the baud rate generator and the receiver itself in separate blocks. But apart from that, this is exactly everything that we had on stage 1. Actually, the receiver on stage 1 already included these two modules, but they were represented within the same block. So, considering that we now need to store the incoming sequence of ASCII codes for the ABC notes, we will obviously need a memory module, so we can add a RAM block. And in this case, the memory block that we have added will have an address bus and a write enable input. And whenever the write enable is activated, the content coming into the input write bus will be transferred to the position that is currently being addressed. The output from the memory comes from the so-called read bus, and in this case we do not need a read signal because whenever we address any given position, the corresponding content will come out automatically. As you may know, the read signal is essentially needed whenever we need to avoid a conflict in the data bus, but in this case we do not have more than one device trying to access the same bus, so we do not need a read enable signal. Now, besides the memory to store the incoming ASCII codes for the ABC notes, we will also need a timer block to generate a new tick every time that half a second has elapsed. And this comes from the specification that we want every note to play for half a second. So whenever we go into the play mode, the timer delay on signal will be activated, and from that moment on, this block will generate a timer delay down tick every half a second. And this will be used to inform the control path that a new address may be generated to send the following ABC note to the code converter. So the addition of the memory and the timer delay have added a few inputs and outputs to the control path, as you see represented here. And with all this information, we are now able to draw the new ASMD chart. Please bear in mind that for every input that comes into the control path, there will be one or more decision boxes in the corresponding ASMD chart. If by any chance, when you have designed the ASMD chart, you find out that some of these inputs have no corresponding decision box, then something is wrong. Either you had represented inputs that weren't really necessary, or otherwise you have forgotten to include some decision point in your ASMD chart. Now likewise, for every output that goes from the control path into the data path, there will be one or more state boxes or conditional output boxes. So once again, if after you have generated your ASMD chart, you find out that one or more of the outputs that are represented here are not shown in any of these state boxes or conditional output boxes, then something is wrong. You have either forgotten to use any given output, or you had represented outputs that weren't really necessary. Starting from this new block diagram then, and considering that in the beginning we will simply be waiting for the UART receiver to signal that a new ASCII code has arrived, we can indicate that the first state in the new ASMD chart shall be looking for the indication from the UART that a new code has arrived. And then it shall check whether it is the vertical bar marking the start of the ABC nodes. If not, then we will just continue in this initial state. Whenever this happens, we will then look for the first ABC code, and so this is the initial states in the new ASMD chart. The chart will comprise 4 groups of states, as you see here, and once the first ABC node has arrived, then we will move into the store states, and this first node will be stored in memory, and then the address bus will be incremented, and we will continue to look for further valid ABC nodes. These will be then the store states. And this will take place until the close square brackets ASCII code arrives, because that marks the end of the tune. So this final ASCII code coming from the ABC file will be stored as well, and we will move into the wait for play signal, which comprises the third group here. And in the wait for play signal, we will wait for the play button to be pressed, or otherwise to receive the indication that a new file is starting to arrive, in which case we go back to the check for ABC state. When the play button is pressed, we will move into the play states, and in the play states we will simply send every ABC code in sequence to the output. We will now take a look to each of these groups of states in sequence. As I have just said a while ago, in the initial state we will be looking for the indication from the UART that a new code has arrived. If this did not happen, then we'll just loop through. Otherwise, we will check if the incoming code corresponds to the vertical bar, which marks the beginning of the section that brings the ABC nodes. If this is not the case, we will continue in this initial state, and what this means is that we will discard every information that precedes the vertical bar. So the heading of this file is discarded. Now, when the vertical bar has been received, we will move into the check for ABC state, where we look for valid ABC codes. So whenever the UART receiver informs the control path that a new code has arrived, we will check if that is a valid code, and if it is not, then we will simply continue in the check for ABC state until the first code arrives. Now notice that we have initialized the address bus at this check for ABC state. So the address bus is now pointing to the first available position in the memory buffer. Now when the first ABC code arrives, we can move on to the store states, and we'll start by activating the write control signal. So the currently received ABC node will be stored in the first position of the memory block. Then we will increment the address bus, and it will point to the first available position that follows. And again, we will wait for a new valid ABC code to arrive. Whenever that happens, we go back again to the store 1 state, activate write to store this code, increment the address bus, and continue within this loop until we get the close brackets ASCII code. That close brackets code will be stored as well, and then we will move into the wait for play state, where, as I said earlier, we will wait for the play button to be pressed. Now, if meanwhile a new ASCII code arrives by the WART, then we will check if that is again the vertical bar, which would mean that a new file has started to arrive. If that is the case, then we will go back to the states where we store these codes. But when the play button is pressed, we will then go to the play states, and in the play states we will activate the timer. And please notice that in all the previous states we have activated the clear flip-flop output, so the loudspeaker is muted. Now when we go into the play states, the loudspeaker is no longer muted. So we activate the timer, check if the current content of the current RAM position is the end of tune code. Otherwise, then we just wait for the half-a-second tick to take place. When that happens, we will continue to activate the timer. We will increment the address bus, so the next ABC note comes out to the converter, and again we wait for half a second. And this is done consecutively until the close brackets ASCII code comes out from the RAM memory, in which case we will go again into the wait for play state until a new file starts to arrive or the play button is pressed once again. Now we are looking into a simulation run where the test bench imposes the sequence of 7C for the start of tune, then 2 notes for B of octave 4, B of octave 5, and then the end of tune code. And then we will assume that we will press the play button twice. So in this initial period, this is when the 4 ASCII codes are being received. Now we don't see the sequence of states because this is compressed in time, but if we zoomed in, we would see that we are within the store states in this period. After the end of tune code has been received, we will wait for a while, then press the play button, and it is at this point that the tune starts to play. Now the first byte to come out from the memory buffer is 70, which stands for note B in octave 4. We will wait for half a second. Actually, I've imposed a much smaller delay for practical reasons, but this would correspond to half a second in the real implementation. And when that takes place, we will increment the address bus. So half a second later, the address bus is incremented. It goes from 0 to 1. The next code comes out to the converter, and the frequency of the output goes from B in octave 4 to B in octave 5. And then we don't see it here in the RAM data bus because its duration is very short. But once we increment the address bus here, the end of tune code will come out, and this means that the timer delay will be deactivated, the clear flip-flop signal will be activated, and we will go into the wait for play state once again. And once the play button is pressed at this point once again, the sequence restarts, and again we go into play 1, and the output waveform takes up the frequency of ABC note for octave 4. Now we are looking at a detailed view of what happens when we go from the check for ABC state into the store states for at the beginning of the reception. So in this case, we started in the init state, we had received the vertical bar, we moved into check for ABC, and at this point we have received a valid code, as you see here. So this was 7.0. So we moved from check ABC into store 1. Please notice that the write enable signal is activated during store 1. This is to be expected since it is what we have indicated in store 1. And then in store 2, the address bus will be incremented. So when we go from store 1 to store 2, within store 2, at the next rising edge of the clock, the address bus will go from 0 to 1. Well, this means that the content of address 1 will come out at the next rising edge of the clock, and we go from 7.0 to undefined because we have not yet stored anything in address 1. We were seeing 7.0 previously because this is what we had stored in address 0. Now, in the second detailed waveforms, we are looking at the moment when we go from wait for play into play when pressing the play button for the second time. So we have played the tune, this was the first note, the second note, then we went into wait for state, and this is the moment when we press play for the second time. So the play button goes up and stays up for a few clock periods, and it is when we detect that we go from wait for play into play 1. And at the same time the timer delay on will be activated, meaning that the timer will start to count for half a second periods, and the first note will start to play, and then we will continue from here as we have seen in the ASMD chart. Well, to conclude, I'd like to leave you with 4 questions. There's no need to read them here, you can do it for yourself. And please, if any of these questions brings you any doubts that you consider appropriate to share with the rest of the class, please post your questions into the class discussion forum. Thank you.